The spinal cord receives and processes information from the body. The spinal cord is also the final common pathway for most voluntary and involuntary reflexive movements. In this animation, we'll examine the spinal pathways involved in the withdrawal of a limb from a painful stimulus. The cell bodies of sensory neurons are located in the dorsal root ganglia. Sensory axons enter the spinal cord through the dorsal roots, where they synapse upon interneurons, which in turn project to the motor neurons. The sensory receptors that transmit the sensation of pain are called nociceptors. Motor neurons are located in the ventral horn of the spinal cord and send their axons out the ventral root to innervate muscles. Some motor neurons innervate flexor muscles, while others innervate the extensor muscles. Whether a particular motor neuron is excited or inhibited depends on the interneuron. In this example, an interneuron sends an inhibitory signal to motor neurons controlling the extensor muscles. An excitatory signal is sent to motor neurons controlling the flexor muscles. This permits the dog to withdraw the hind limb from the painful stimulus. With the withdrawal of one limb, the weight shifts to the contralateral limb. Interneurons also connect to motor neurons on the opposite side, so that the muscles in the other limb can adjust to the shift in weight distribution. Flexion of the stimulated limb is therefore accompanied by an opposite reaction in the contralateral limb. That is, the extensor muscles are excited, while flexor muscles are inhibited. The sensory information is also relayed up the spinal cord to the brain, where it can be further processed. Ultimately, signals from the brain travel back along motor pathways down the spinal cord and can thus modify the actions of the spinal circuits. The information from higher nervous centers permits fine-tuning of muscular control and also allows the dog to avoid painful stimuli in future encounters.